Hello, everyone. Welcome back to the channel. Today, we are diving into a fundamental topic in chemistry, acid reactions. To begin, let's clarify what acids are. Acids are substances that release hydrogen ions. Okay, so remember, they release hydrogen ions. To get a detailed understanding of what acids and alkalis are, please check out my video so that you understand it better. So this is a brief introduction to acids, so which release hydrogen ions and when they are dissolved in water. So this is a very important aspect. So they release hydrogen ions when dissolved in water. So this is a key characteristic that distinguishes them from other substances. It's essential to understand what aqueous and liquid are, the difference between aqueous and liquid. Many of my students get confused with these terms, aqueous and liquid. So remember, aqueous is something when it's dissolved in water. Okay, so liquids, they are kind of, they are the pure form, they are the state of matter. So now let's look at a few examples of acids, including hydrochloric acid, sulfuric acid, acetic acid. So these are a few examples. So this is just an introduction. So remember the key points. They release hydrogen ions when dissolved in water. So they are in solution. So acids and alkalis both, they are always, dissolved in water. They are in aqueous solution. So acids are substances that have a sour taste and can react with metals. There are three major reactions, chemical reactions, in which all acids will take part. Now, these reactions are best seen using dilute acid solutions. So in these reactions, the acid reacts with a metal acid. It reacts with a metal acid, example, magnesium or zinc. So the metal dissolves, forming salt and hydrogen gas. So we will look into it in detail in a few moments. The next reaction is an acid-base reaction. This is a neutralization reaction forming salt and water. And the third reaction is an acid-carbonate reaction, the metal carbonate or hydrogen carbonate, and it gives salt, water, and carbon dioxide. So we will look into all of these one by one in detail. Metals are quite reactive. They can be used to displace the hydrogen from the acid safely. Plus acid, they produce salt plus hydrogen. So it is unsafe to try this reaction with very reactive metals. So if you check the reactivity series, it is unsafe to try this reaction with very reactive metals such as potassium, sodium, calcium. The reaction becomes too violent. So it's better not to try acidic reactions, acid and metal reactions in the lab with these highly reactive elements. So no reaction occurs with metals such as copper, mercury, silver, gold. So even with lead, if you see, even with the lead, it is difficult to see any reaction in a very short time. The reactivity of metals with acid, is considered, mainly the acids that we are going to use. The salt made depends on the acid reacted with the metal. For example, the hydrochloric acid always, remember, hydrochloric acid will always give a chloride. It will always give a chloride. So if you're going to, whatever the salt is made, depends on the acid reacted with the metal. So if it is hydrochloric acid, it will always give a chloride salt. If it is going to be nitric acid, it will always give a nitrate salt. So you all have to remember this. This is an easy way to remember. So whatever the acid is, whatever the acid reacts with the metal, that salt will be made. So if it is going to be sulfuric acid, come on, think about it. Pause this video here, answer, and then check. Yes, it will be a sulfate salt. So whatever the acid is, if it is going to be hydrochloric acid, it's going to be a chloride salt. If it is going to be nitric acid, it will be a nitrate salt. And if it is sulfuric acid, it will be a sulfate salt. So remember, when metals react with acid, they produce salt and hydrogen gas. So you can write the reaction like this. So a metal reacting with an acid will give you salt and hydrogen. Salt plus hydrogen. Fine? Is this clear? Now, remember, for example, now we just saw that if it is hydrochloric acid, then it always gives a chloride. Now that salt, the salt that is formed, the cation comes from the metal. So whatever the metal is, the cation comes from the metal and the acid gives the anion. Let's see an example. If you are going to take magnesium, okay, magnesium is a metal, and if it reacts with, say, nitric acid, now tell me what kind of salt will be made. So you will get the cation from the metal. So what is the cation here? Magnesium. So magnesium is the cation. And what is the anion? It is from nitric acid. What is the anion that you will get? Nitrate. Yes, you guessed that right. So along with the salt, what else is produced? It's the hydrogen gas. So plus hydrogen. So this is how you make your equation. So this is one example. Now try to write the chemical equation for this. Pause the video here and try to write the chemical equation for this. Okay, so hopefully your chemical equation, you have magnesium. Remember to write the state symbol. It is a solid. So when it reacts with nitric acid, HNO3. Now remember, acids always are in solution. So aqueous. So what does it give? It gives magnesium. Now how are you going to make this formula? Magnesium, remember magnesium, the cation is from the salt, anion is from the acid that is going to, that reacts. So this is nitric acid, so it's going to be a nitrate. So magnesium, what's the valency? It's 2 plus. And what is the valency of nitrate? It's -1. So just swap the valencies, you get the formula. So it is Mg, and here it's 1. So you don't write the 1 subscript. You don't write it. NO3. Yeah, so what's the subscript for? What is the valency of magnesium? That's going to come here, and that becomes the subscript. So NO3, 2. So MgNO3, 2. So this is the formula for magnesium nitrate. And what is the state symbol? It's aqueous. And what else do you get? You get hydrogen. Remember, when metals react with acids, you get hydrogen gas. So the state symbol is G. Okay, so this is how. Now, don't leave it this way. It has to be balanced. So check that out. How many magnesium atoms are here? So there is 1 magnesium, so 1 magnesium in the product side. What about hydrogen? So there are 2 hydrogen atoms in the product side, and in the reactant, there is only 1. So you add in the coefficient. So this is called the coefficient. So 2. So here, this is 1, which we don't write. So 2 ones are 2. So 2 hydrogen atoms are produced. And here it is, yeah, so nitrogen 2 and nitrogen 2 here in the reactant side. Oxygen, it is 2 3s are 6. And here too, it's 2, 3, 3 2s are 6. So now the equation is balanced. Now try writing an equation for a chemical equation for zinc when it reacts with hydrochloric acid. So now I want all of you to pause your video here and try writing the chemical equation for zinc when it reacts with hydrochloric acid. So what does it give? Okay, so now that you've paused, I hope you have got, what do you get? The cation is from the metal. So it is zinc. And what is this? Hydrochloric acid. So from this hydrochloric acid, what is the anion that you will get? You will get chloride. So it is zinc chloride. And what is the gas that is produced? It's hydrogen gas. So now try writing the chemical equation. So what is the chemical equation? Symbol for zinc is Zn. Remember to write the state symbol. It's a solid. HCl is the chemical formula for hydrochloric acid. Remember, it's always an aqueous, acids in aqueous. Now, how are you going to do the formula for zinc chloride? So it is going to be ZnCl2. Remember, you have Zn. Now, Zn, what's a valency? It's 2 plus. Chlorine, chloride ion, it's -1. So you simply swap the valencies to get the formula. So here you have Zn. Yeah, you don't write the coefficient 1. So Cl2. So ZnCl2, which will again be aqueous plus hydrogen. Hydrogen is a diatomic molecule, so it will always be H2, and the state symbol will be gas, G. So now balance the equation. So what do you find here? You find that hydrogen is 1 atom here, whereas in the product side it is 2. So you just add a 2 here to the coefficient, and now you have a balanced equation. So reaction of acids with bases and alkalis is a neutralization reaction. Acid plus base will give salt and water. And the salt that is produced here will depend on the combination of the reaction, like what acid you're going to use or what base you're going to use. It depends on that. For example, if you see HCl, take HCl. Now HCl, what is the state symbol? It's aqueous. Base also should be aqueous. Remember this. Base should also be aqueous. So if we have taken a base, say sodium hydroxide, the salt that's going to be produced is going to be NaCl, sodium chloride. So this will also be aqueous. And along with it, you will have water that will be a liquid. So remember, acid plus base will always give salt and water. So this is the general equation for a neutralization reaction. And if we take HCl and NaOH, we get NaCl. So the cation and the anion, the salt depends, the compound depends on the reactants that are used. Now, in this reaction, we can see that the hydrogen ions of the acid, so you see here, the hydrogen ions from the acid are matched by the hydroxide ions. So here you see the hydroxide ions. They are matched by the hydroxide ions from the alkali, and they produce water. Remember, a neutralization reaction is where the hydrogen ions are equal to the hydroxide ions. So here, that's the reason you get water here as a product. And remember, don't forget the state symbols. always the acids and bases are in aqueous. But here, water is a liquid. So I hope this is clear. So this is how neutralization happens. And what happens to the pH? pH is equal to 7. So acids, when they react with hydroxides, they form salt and water. So remember this, that, the salt that is going to be formed, again, it depends on the acid that we are going to use. For example, if we are going to use HCl, okay, let's say HCl. So if we are going to use HCl and react it with potassium hydroxide, KOH, if we are going to react it with potassium hydroxide, what is the salt that will be produced? It is going to be the metal cation, and it's going to be the chloride. So it will be KCl. And of course, water will be produced. So you balance this equation. And if we take sulfuric acid, H2SO4, and react it with potassium hydroxide. So what do we get? I think by now you know how to do the formula, how to make the, the chemical formulae of the compounds. So take the valencies, just swap them. So valency of potassium is +1 and sulfate is -2. So here you swap the valencies and you get the formula. So plus water. So make sure the equation is balanced. So you have 2 hydrogens here and 2 hydrogens here. Okay, that's balanced. But then you have another hydrogen here. So it's going to be 3 hydrogens and 2 hydrogens here. So let's add a coefficient here to make it 4. So another 2 here, so that, even your K2 is balanced. Oxygen is 4 plus 2, 6. And here, oxygen is 4 plus 2, 6. So I think the equation is balanced now. So what did you get? You got K2SO4. And now let's take the next acid. Now, as IGCSE students, you should know these 3 acids and the reactions with acids. So with the next acid is nitric acid. And when you react it, what do you think? Now pause the video here and try to get the answer. So this is what you get. See if it is balanced. See if the reaction is balanced, because never leave an equation unbalanced. Now let's work out another example. Here the base is an oxide, a metal oxide. And this is again a neutralization reaction. This can also occur by reacting an insoluble base with an acid. So let's take an example. As you know, in a neutralization reaction, salt and water is formed. And what is that salt? A salt which has the cation from the metal oxide. So let's take an example where we react, say, magnesium oxide. Remember the state symbol, solid. It reacts with nitric acid, HNO3. So remember HNO3, aqueous. What does it give? So the cation will come from the metal. So what is the metal oxide here? The cation is from the metal. So magnesium. So it will be Mg, and the acid is nitric acid. So what is the anion that we will get in the salt? It will be nitrate. So NO3, 2. So MgNO3 plus, of course, it's a neutralization reaction. So you will have water produced. So this is also aqueous. The salt is also in aqueous, and water is liquid. Now, how do we get the water? Water is a byproduct of the reaction. It is useful to realize the origin of the salt. So how do you get the salt? Because it helps you to predict which salt you get from a particular combination of acid and base. So if whatever the base is and whatever the acid is, it's better for you to understand how you get the salt. So, sodium chloride comes from the neutralization of hydrochloric acid and sodium hydroxide. That is how we began. Now, in this example, magnesium oxide and nitric acid, you get magnesium nitrate. So remember, the next thing is the reaction of acids with carbonates. All carbonates, they give off carbon dioxide when they react with acids. So remember, carbonate, remember, that's a clue. Carbonate, so carbon dioxide. They give out carbon dioxide when they react with acids. So we have seen that this reaction occurs with the effervescent antacid tablets. If you are going to dissolve an antacid tablet, there is an effervescence. So that's carbon dioxide that is released. So the result is to neutralize the acid and produce a salt solution. So here, when an acid reacts with a metal carbonate, when it reacts with a metal carbonate, what is produced? You have salt, you have water, and you also have carbon dioxide. Okay? So remember, when acids react with carbonates, they not only give salt and water, but also give carbon dioxide. So the normal method of preparing carbon dioxide in the laboratory is based on this reaction. So you must know the usual experiment that is done. It is using dilute hydrochloric acid. They use dilute hydrochloric acid with when it reacts with marble chips. So marble chips, what is the chemical name for marble chips? It's calcium carbonate. Let's write the state symbols. So calcium carbonate is a solid. And when they react, what is the salt that is produced? Remember, the salt comes from the metal carbonate that you have produced and the acid. So here it is calcium. And since it is a hydrochloric acid, the anion will be chloride. So this is going to be aqueous, and you have water produced along with it, which will be liquid, and you have carbon dioxide gas that is produced. Okay, now remember in your chemical analysis chapter, when an unknown salt is given to you, if there is an unknown salt given to you, the test for a carbonate is based on this type of reaction. How will you test your unknown salt? So if you react the acid with the salt, what do? The carbon dioxide that is given off, that is tested. So what is the test for carbon dioxide? So when an unknown salt, imagine, an unknown salt is given to you, you add hydrochloric acid and there is a gas given off. Now, to confirm if it is carbon dioxide, to confirm whether it's carbon dioxide, you, make sure that this carbon dioxide, is bubbled through lime water. And if there is carbon dioxide, it will turn milky. So can you see the picture? So if carbon dioxide is bubbled through lime water, so this is lime water. If it is bubbled through lime water, then it will turn milky. So this is a positive test to show that there is carbon dioxide. And if there is carbon dioxide, it means the salt that has been given to you has a carbonate. It has a carbonate. So you have found the anion now. So you have found the anion. Now to find the cation, what do? To find the cation, you do a flame test. You will do a flame test. And here, while you do a flame test, if you get the flame to be orange red, so this is orange red. So if you get the flame to be orange red, you confirm that the cation is calcium. So that's how you conclude that the unknown salt is calcium carbonate. And I think you know the flame tests, the different colors, the different flames. So if it is lithium, it is a red. If it is sodium, it's yellow. If it is potassium, it's lilac. Don't say purple, say lilac. If it is copper, it is blue green. So I think you know the flame test. So if an unknown salt is given, you just add a hydrochloric acid. And if there is any bubbles that are coming out, you do a carbon dioxide test where you just, use those bubbles. You just put them in lime water. It turns milky, which confirms that there is a carbonate. And for the cation, you do the flame test. Thank you for watching Score Stars. Please subscribe, share, and like. Bye bye.